Hi, my name is Mrs. Wade, and I'm going to be doing the lesson on 8.1 exponential models. This is part 1 of this lesson. There are 3 parts. Models you already know from Algebra 3-4 and Algebra 1-2. You already know about linear. Those are straight lines. They're usually in the form y equals mx plus b. And as you know, lines look like this. Quadratic, we learned already, that's parabolas. So there's different forms, but ax squared plus bx plus c is your standard form. And parabolas look like that. So if your data looks parabolic, you would have a quadratic equation. If it looks linear, you would have a linear equation. And we also just learned in the last chapter about square roots. And they can look a lot of different ways moving around, but that's the basic parent function. So today you're going to learn about a different type of function called an exponential function. So the general form of an exponential function is y equals a times b to the x. So let me tell you what all these pieces mean. So the a is the y-intercept. Or if you're talking about word problems, it's your initial value. So if you're trying to find out how much something is growing, A is what you start with. B is called the growth factor. We're going to learn in this chapter that there's 2 things, there's growth and decay. So that just changes the B. We'll talk a little bit about that in some other problems, but here's the basics of that. If your b is greater than 1, that means your exponential function is going to look something like this, and we call that growth. If your b is less than 1, your graph is going to look something like this, and we call that decay. So we have exponential growth and exponential decay. The only difference is the value of b, whether it's a whole number greater than 1 or a fraction. So you'll see examples of both of those. Okay, we're going to start with a basic problem to go through all the steps and then do a few other examples. So y equals 2 to the x. We're going to start with that. You always want to make a table first when you're first learning this, but after a while you're going to understand the patterns and you're not really going to need to be making tables. But for this first problem, we're going to. So to make a table, I'm going to put in some values for x. I'm going to start with these values. Doesn't really matter. So if I put in -1, that gives me 2 to the -1. 2 to the -1, if you remember a negative exponent, means it moves it to the bottom, and the exponent becomes positive. So it'd be 1 over 2, which is a half. Okay. If I put a 1 in here, anything to the 1 power is itself, so that's a 2. When I put in a 2, 2 squared is 4. And anything to the 0 power is 1. So there's our points that we're going to graph. So we're going to go over to -1 and then half, 1, 2, 2, 4, and 0, 1. Okay. So here are some basics for this. See how this is dipping down, getting closer and closer to that axis? That axis is actually an asymptote. Exponential functions have what we call a horizontal asymptote. And the horizontal asymptote for the parent function is y equals 0. It's a horizontal line, so this graph is approaching that line but will never cross it. Okay? Also, what do you notice about the y-intercept? If you look at my graph, it crosses the y-axis at 1. So it has a y-intercept at 1. Okay? So these are some basic elements of exponential functions. They have an intercept, a y-intercept at 1, and a horizontal asymptote at y equals 0. So those are the main things you need to remember. So let's try another example. Let's try y equals 3 times 2 to the x. So remembering all your pieces that we just talked about, the 3 is the y-intercept, and this is your b, which is your growth factor. Because it's greater than 1, I know it's going to be growth. So my general graph is going to look, it's going to go up. If it was less than 1, it would go the other way. Okay? Like that. All right, we're actually going to graph this. So we also know, because this doesn't move around at all, that it has a horizontal asymptote, and I'm going to use HA for my abbreviation for horizontal asymptote at y equals 0. In the next part, we're going to be moving these around, so this will obviously move, but for right now, because it's not shifting around, it's going to be y equals 0. So at y equals 0, I draw a dashed line. There's my asymptote. My y-intercept is at 3, 1, 2, 3. And because my b is bigger than 1, I know it's going to be growth. So you're just going to draw a sketch. You don't need to do any other points to make that a little bit more accurate. It's fine like that. Okay? So the main things you need to remember, the 3 in front's the y-intercept. The 2 is the growth factor, which means it's going to grow up instead of starting this way and going down. Why don't you try y equals 2 times 1/2 to the x on your own? Go ahead and pause this video and try it yourself to see if you can do it, and then restart it again so you can see my solution. Welcome back. Let's see if you were able to do this problem on your own. So the 2 was the y-intercept. This was the b, which is my growth factor. Since it's less than 1, hopefully you remembered from the first part of this that it goes that way. Okay? So we're going to put in our horizontal asymptote is y equals 0. So those are the main parts. So we're going to go ahead and graph it. So at y equals 0, we're going to do our asymptote. Our y-intercept is 2, and because it's a half, it's exponential decay, so it looks like that. Okay, very good. Hopefully you guys all got that. So let's talk about just a little bit of a pattern. I know that y equals 2 to the x has an intercept of 2, and it goes like this. What happens as the 2 gets bigger? So let's say I had y equals 4 to the x, y equals 8 to the x. What is happening to that graph? So let's take a quick look here. I'm going to put this underneath here so you can see. On my TI Inspire, I've graphed the y equals 2 to the x, and that gives me the blue graph. And let's say I want to graph y equals 4 to the x. So I do 4 to the x. What do you think is going to happen? Let's see. Oh, it looks like it's getting steeper. Okay. If I want to try putting in one more just to see what happens, if I wanted to put in 8 to the x, and there's the black lines. We have the blue, which is the original, the red, which is the 4 to the x, and the 8 to the x, which is the black line. It's getting steeper and steeper. So basically, as b gets bigger, the graph gets steeper. That's the end of part 1.